Hi student, welcome back to class, and this is Odison Alekon Adiola, your favorite chemistry teacher. Um, in today's class, we are going to be starting up with water of crystallization. I'll still come back to gas law later on. So these are questions on water of crystallization that we are going to solve. First and foremost, we need to look at what is water of crystallization. In acid, base, and salt, uh, we have two types of acid based on the amount of water, the amount of salt rather. We are looking at two types of salt based on whether they have water or not. We have what is called the anhydrous salt. Anhydrous salt. For anhydrous salt are salts that do not contain water of crystallization, e.g. Na2CO3. Na2CO3. So these salts do not contain water of crystallization. And then we have another salt called hydrated salt. Hydrated salt. An example is Na2CO3.10H2O. Now the difference between this and this is that this is anhydrous, does not contain water of crystallization. This contains water of crystallization. In most cases, a salt become hydrated when it undergoes crystallization, or when it is exposed to atmosphere and it absorbs some water to the atmosphere, and it absorbs some water, as the case may be. However, these molecules of water we are talking about, they are loosely bound to the salt when it is crystallizing. So the term water of crystallization now is now referred to the number of molecules of water that is loosely bound to a particular salt when it is crystallizing. So most salts usually have water of crystallization. Most salts usually have, talk of iron sulfate, talk of zinc sulfate, talk of calcium chloride, etc. All of them usually have their water of crystallization. So the essence of calculating the water of crystallization is that, so we are able to find out what water of crystallization each of these salts contains. And of course, you should take note that if they contain water of crystallization, when there is heat, for instance, if you have Na2CO3.10H2O, if it undergoes heat, with heat you can have Na2CO3. This is, let's call this one aqueous plus 10H2O. So with heat, it is possible that they lose that water of crystallization. That process, that what's it called, is called efflorescence. Okay, so in the next video we are going to be looking at some calculations that has to do with water of crystallization. I know a lot of students usually have problem with this, and that is why I want to do that. Now before I quickly round off, let's have formula for water of crystallization. How do we calculate water of crystallization? To calculate water of crystallization, we are going to have we can have mass of hydrated over mass of anhydrous. Mass of anhydrous is equal to molar mass of hydrated over molar mass of anhydrous. Now this is basically the first formula. However, in reality, most of the questions they are going to be giving you has to do with open-ended question, where they go specifically to you finding the water of crystallization that contains. So preferably you can now say mass of water loss, the mass of water that is lost, because a particular what's it called, a particular salt can lose water so that it can become hydrated or anhydrous, as the case may be. It lose water to become anhydrous. So the mass of water that is lost all over the mass of the anhydrous salt is equal to XH2O over molar mass of anhydrous salt. So this is the most important formula that we usually use. The mass of water will be known in the question. The mass of anhydrous, when it cruises water, of course it becomes anhydrous. The mass of anhydrous, then this X now signifies the number of molecules of the water of crystallization, which is what you are always looking for, and then the molar mass of an anhydrous salt. Okay, so this is what we are going to be using to solve the following question. I hope you learned one or two things. May God bless you. Of course, do well to read up on this topic, so that when we start the calculation, it can be easy for you. Thank you, and may God bless you.